Let's do one problem for De Morgan's second law. Example number 2. If the union set U equals to A, B, C up to Z, X equals to A, B, C, Y equals to E, F, G, up to V. These are the three sets. Let me solve the De Morgan's second law. From the left side of the De Morgan's second law that we have, which is X intersection Y to the whole complement equals to U minus X intersection Y. Plug in the value of U, which is the union set, with the elements A, B, C up to Z. Plug in the value of X, which is A, B, C, and plug in the value of Y, which is E, F, G up to V. Now first, to take the intersection of these two sets, inside this blue parenthesis, let me first take the intersection of these two sets. So their intersection will be empty set. We know that in intersection we take common elements. Is there any common element in both of the sets? No, we don't have any common elements. In set A we have A, B, C, but in set B it starts with the E, F, G up to V. So there is no such common element that we take for the intersection set. Therefore we're going to put empty set. Empty set. This is the notation for the empty set. Whether you put this symbol or empty space inside the braces, it is up to you. It is the empty set, which is my X intersection Y. Now to take the difference with the U, which is the union set. U is the union set, remember. So we're going to take difference with the U here. Look, X intersection Y to the whole complement equals to U minus X intersection Y. It is exactly like A complement or B complement. So A complement equals to U minus A, B complement equals to U minus B. Similarly, X intersection Y to the whole complement equals to U minus X intersection Y. Now to take the difference of these two sets. So their difference will be A, B, C up to Z. The difference of these two sets will be the set with the elements which are only belonging to this set, not with this one. Is there any such element which belongs to this set? No, there is no such element. All the elements of this set belong to this one, which are from A, B, C up to Z. Is there any common element between these two sets? No, there is no such common element. Therefore, we're going to put all these elements for the different set, which is from A up to Z. So there you go for the answer for the left side of the De Morgan's second law, which is X intersection Y to the whole complement. Let me give the name equation number 1. Now to pick the right side of the De Morgan's second law, X prime union Y prime equals to U minus X union of U minus Y. Look here, what is my X prime? My X prime is U minus X. My Y prime is U minus Y. Last time we had A, B, but this time we took X and Y. You can give any name to the sets. You can give the name D here G, whatever name you want to give, you can give. So X prime equals to U minus X, Y prime equals to U minus Y. They are enclosed separately inside the brackets with the union. So plug in the value of U, which is the union set, A, B, C up to Z. Plug in the value of X, which is A, B, C. Then plug in the value of U again, which is the union set, A, B, C up to Z. Plug in the value of Y, which is E, F, G up to V. Now to find the different sets, let me find the different sets separately for these two sets and also for these two sets. So their different sets will be E, F, G up to Z. This is the different set of these two sets. Look, the different set of these two sets will be the set with the elements which are belonging to this set, not to this one. If we put the second set at the place of the first set, then we're going to have all the elements which are belonging to this set, not to this one. But since this is my first set, we are subtracting this set from the first one. So the elements will be only from the first set, not from the second set. I just refreshed the difference of the sets. If you're still confused, please just go back and check the section where I have done the difference of the sets. Look, in second set we have A, B, C. So A, B, C will be cancelled with the A, B, C. After C we have E. the elements will start from E, comma F, comma G up to Z. Because remember A, B, C are repeating here, so they will be cancelled. We will take initiative with the E, comma F, comma G, comma H, comma I up to Z. Similarly, the difference of these two sets will be A, comma B, comma C, comma D, comma W, comma X, comma Y, comma Z. The difference of these two sets will be the set with the elements which are only belonging to the first set, not to the second one. In the second set, we have the elements from E up to V. So all the elements from E up to V will be cancelled with the elements in this set. So the elements in the first set, other than these elements which are from E up to V, will be the elements of this set. What are the rest of the elements? We have A, comma B, comma C, comma D, comma W, comma X, comma Y, comma Z. We have A, comma B, comma C. These are the elements which are not belonging to this set. And then from E up to V, we have the elements in the second set. So we're going to ignore the elements from E up to V. They will be cancelled with elements from E up to V here. What are the rest elements? From V onward, we're going to put the elements for this set because it is a set of complete alphabets. So the elements onward of V, we have W, X, Y, Z. These are the elements which are only belonging to this set, not to the second one. So there you go for the different set of U minus Y, which is my Y prime, and this is the different set of U minus X, which is the X prime. Now to take their union, the union of these two sets will be A, comma B, comma C up to Z. This will be the union set of these two sets. Remember, in union we take everything, we take all the elements from both of the sets, except those elements which are repeating. We're going to pick only the common one. In second set we have A, B, C, D, W, X, Y, Z. These are the elements which are existing here as well. Look, W, X, Y, Z are the elements in the second set which are repeating in the first set as well. So we're going to take the common ones and then we'll put the rest of the elements as they are. It starts from A, comma B, comma C up to Z. This is the union of the elements of these two sets. This is the combination of all the elements of these two sets. So let me give the name equation number 2. In equation number 1, which is the left side, we have A, comma B, comma C up to Z. It is the set of all English alphabets. Similarly, in equation number 2, which is the right side, we have the same set, which is the set of all English alphabets from A up to Z. So we can write that from equation number 1 and 2, left hand side equals to the right hand side. Hence, x intersection y to the whole complement equals to x complement union y complement. That's what we have proved in equation number 1 and 2. That left hand side equals to the right hand side.